We will spend today and tomorrow on this. All right, so here we go. 6-3. What does that equal?
$16.
16, yeah.
And how did you get that?
Well, I know that 2 to the third is 8 just off the top of my head, but if I was doing 2 to the third, it's like 2 times 2, which is 4 times 2, which is 8. And then I did 8 times 2 is 16.
Yeah, let's take 2 times 2 times 2 times 2, right? And this is 4, and then 4 together gets 16, 4 times 4. You can do it that way. You can do 2 times 2 is 4, times 2 is 8, times 2 is 16, right? So that's what this means, okay? Taylor, do you have a question?
No, I don't know why I was unmuted.
You're okay. All right, so there's this thing that we're going to talk about today that talks about changing the form of this, which goes log and then 2 16 equals 4. These two things right here, this right here and this right here, are the same exact thing. It's like me if I write 1/2 and I write 1/4. I'm sorry, 2/4. These guys are exactly the same. They're just in different forms. These guys right here are exactly the same thing. They're just in different forms. Now notice, this is called the base. This is called the exponent, and basically this is the answer. Well, if you look down here, the base went right here, the answer went right here, and the exponent went over here. So if I asked you b to the x equals y, right? Because it doesn't matter what b is, it doesn't matter what the number the x is, it doesn't matter what number the y is, it matters its location. What would you write in log form? Can someone help me out? Try it.
Log and then b to the y equals x.
So it's actually, yes, you're right, but we say it's actually, so log base b y equals x. So this is actually all the number. This is actually the subscript. So y is not to a power here. So don't think of this as b to the y power. It's not. B is actually a subscript. Does that kind of make sense so far?
Yeah.
So try to change this one. I'm going to give it to you in power form. I want you to change it to log form for me. Change that to log. Did anyone get an answer?
Log subscript 4 81 equals 3.
No. You switch one of those. The base here stays the base when I do log. So it's not log 4, it's log 3.
81 equals
81
4.
equals 4, yes. Boris, does that make sense?
Yes.
Go ahead and give me a thumbs up if that makes sense. I need everyone to know this. This is going to be like, this is so important for us moving on when we go to the next sections. You got to be able to change back and forth between these two forms. All right, try again with this one. What form is that in?
Log form. I don't know how it's called.
It's log. This is called log form. So what are we going to change it into? Change it into exponential.
Could I answer it?
Sure.
Wouldn't it be 3 and the exponent would be 5 and it would equal 125?
Close. So this is the base here. So it becomes our base in our next question. So you kind of did the same thing that Oris did. So switch the 3 and the 5.
Oh, okay.
So it's the base down here as well as the base here.
Mm-hmm.
And then how I do this is this is how I would always did it when I was like learning this. I went 5 to the third equals that. So 5 to the third equals 125. And that makes sense. And by the way, you can check this because if you had done 3 to the fifth equals 125, you could check that in your calculator. And if you would have put 3 to the fifth in your calculator, 3 to the fifth, 3 to the fifth, that actually equals 243, which is not 125, so that's incorrect. But if you actually take 5 and take it to the third power, it does equal 125.
Makes sense though, yeah.
Now, the reason that we are teaching you this is because notice what happens when I do, let's go back to when we just did log 5, 125 equals 3, right? When I have it in this form, there's an exponent, right? The 3 is the exponent. When I have it in this form, there is no exponent. There is no exponent when it's in this form. So how you can use this is, do you remember when we had our PERT formula? Well, sometimes in life, I know how much I start off with. Let's say I start with $5,000. And I know E, and I know I'm going to get a 2.5 interest rate, so it's 0.025. And I know I want this $5,000 to turn into $10,000. What could I figure out now? Or what would I need to figure out?
How much time it would take?
Yeah, how long is this going to take for this $5,000 giving me continuous interest at 2.5%? How much time is it going to take for it to turn into 10 grand? And the problem is the T is in the what spot?
It's an exponent.
And you won't be able to find how to solve for T when it's in the exponent spot. But thank goodness what we learned today is we can get rid of this power form and turn it into log form, and then there is no exponent. So that's what the rest of this, you don't need to solve that right now. I'm just trying to show you why we're doing this and how the point of it is going to be. That's just a small example of how it is. Some things you need to know that are by definition. if you see just the word log, it is what we call common log, and common log always has kind of like a hidden 10 here. This will not be written. That's why I wrote it in yellow. It will not be there. All you will see is the word log, and when you see that, you understand it is what we call common log, meaning base 10. And you can actually find this one. It's the only one that you can actually do log on your calculator. So if you go to your calculator, I will turn mine on for a second. And if you look at my calculator, right at the underneath the second, you see the word log. That's the log button right there. And that is log base 10. So we can actually use our calculator to do this one. So all you do is you hit log, and then you'd hit, I'm trying to do this backwards. This is fun. 900. And when you do that, you'll see, hopefully it's reflecting, but you see it's got log 900, and then you hit equals, and it does that number for you, which I'm not going to attempt.
It says error when I put log 10.
No, you don't have to put log 10. You just leave it like this. It already knows that it's a base 10, Orist. You don't have to put the 10 in.
Oh.
So you just hit log and then 900. What kind of calculator do you have? Put your calculator up to the screen for me, Orist, real quick.
I'm using my phone.
Okay, so you're using your phone. So I think in the phone, you have to.
I have a scientific one. Wait.
But if you did your phone is a little different. As soon as you hit the log button, it takes the log of whatever number is up on your screen. So I think on this one, you have to hit 900 and then hit log. So sometimes you have to learn how the calculator works.
Yeah, I got it.
Everyone should be trying that on their calculators. If you do that, that should mean 2.9542, around there. Why does that answer make sense, by the way? Make that make sense for me. What does this really mean? It really means, right, this is log base 10, 900, and we're trying to find what that equals. So this is our unknown, right? So that means 10 to the, whoops, brain got a little fast. 10 to the x equals 900. Well, let's think about this. What's 10 to the first power? Come on.
Just 10.
10.
Thank you. What is 10 to the second power, Jonah? Remember, if I call you, you do not answer, you will be good. Thank you. 100. For some reason, yours isn't coming through, Jonah. And what is 10 to the third power? Dominic?
1,000.
Now, let's look at this number right here. We wanted 10 to some number equals 900. Where does 900 fall?
In between 10 to the second and 10 to the third.
It falls right in between here and even closer to the 1,000, correct? So if our x should be some number between 2 and 3 and closer to 3. And if you look at our number we found it to be, it is almost right on 3. It's 2.95, which is exactly what we expected based on our kind of understanding of what we were solving for. Does that make sense? Give me a thumbs up if it makes sense. All right. If you ever see this, have you seen this? This is an L, by the way. It's an LN. Has anyone ever seen this? It's on the calculator as well. It's normally right next to the log button. That right there actually means you are doing log base E, but you will never see it written like this. You will never see it written like that. You will see it written with this. And if you think about it, it stands for natural log. So natural log. It is with base E. Haven't we seen E before? We just saw E. Where? Right there in that PERT formula. And sometimes we have to use E to get things out of the exponent. So we'll have to use natural log. So that's what that stands for. And so if you ever ask, so someone says, what's the ln of negative 1.87? Go ahead and put that in your calculator. And what do you get? Come on, someone put that in the calculator. Tell me what they get. Boris, did you put it in your calculator?
No, but I'm good. I'll do it right now.
Yeah, put it in your calculator. Tell me what you get. It's on.
0.625.
No. Something went wrong. Did you put it exactly like this in there?
No, but let me get my scientific calculator.
Or Orist. Take your phone, it's fine. Hit 1.87 and then hit the negative sign. Then hit ln.
I just keep getting an error.
Yeah. No, that's why I was asking. I kept saying, what do we get? I needed you to get an error. Why does that make sense? What does this really mean, guys? Change this to power form. This is an unknown, right? What is my base here? It's E. So it's E to the X equals a negative 1.87. Is there any number that you can put in for X that will make E a negative number? This is 2.7 something. So can you take 2.7 something and raise it to a power and kick a negative? No. If you put a positive number in here, this still kicks positive. If you put a 0 in here, this is 0. If you put a negative in here, what does the negative exponent do? We've covered this. What does the negative exponent only do?
It makes the number smaller.
Not always. Not always. Be careful on that. It sends it to the opposite. So if it's in the numerator, where does it send this to?
The denominator.
But it doesn't make it negative. There is no way that you can make e to some power a negative. That's why you kept getting error, because it's not possible. Does that make sense? Give me a thumbs up if that makes sense. All right, now here's why we use this. Can you solve for the x in this question right now the way that it's written? Do you know how to pull the x out of the exponent?
No.
No, but what do we know how to change this to? What form is this in?
Exponential. We can
Can we
change
change it to log?
Mm-hmm.
Okay, what would be the log? Go ahead and try it on your own and see if you get what I get. You should get log. This is the base, so that's the number that's going here. Since it's a 10, technically I don't have to write it, but since we're practicing it, I'm going to put the 10 there for you, but normally that won't be written there. Whatever that equals goes right next to it, so the 25 goes here, and that equals x minus 1, right? What can I do with this actually now? Because it's base 10, what did I tell you you can use?
we can just do log 25.
in your calculator. And if you do, you get an answer that is about what, 1.398, and that equals x minus 1. And then you add 1, and you get 2.398 equals x. So right here, you weren't able to solve for the x because it was left up in the exponent. When you change it to log form, it is no longer an exponent. And because this is base 10, you're able to get an answer by using your calculator that turns it into this number. You add the 1, and boom, you've got your x now.
What exactly is log?
Isn't this what this is?
Yep.
So it's like the operation that tells me that this means 10 to the second power equals 100.
Okay.
These guys, that's why I was trying to get you guys to understand these guys are the same. So it's like the opposite of 10 to the second. It allows me to change the form that it's in so that when I have an unknown and an exponent, it's no longer an exponent over here. It's just a regular number, which means I can actually solve, like I can get to it. When it's up, when the variable is up in the exponent, I can't get to it. So it allows me to pull it down. It's an operation. Does that help, Boris?
Yes.
All right. Can I normally do LNs in my calculator? Yes or no?
No.
Can I normally do LNs in my calculator? Yes, you can. We did it, right? LN 5. If you wanted to do that, you could put that in the calculator. You just hit 5, and for yours, Oris, you'd hit 5, then LN. On my calculators that in class, I'd hit LN. It would put a parenthesis. I would put a 5, close it, and hit equal sign, and it would give me a number. But why can't I do that for this example? Because I don't know what that x is. So I would have to do 2 times x, then I would add 3, then I would do the ln. Well, I can't do that. So in this case, my ln or my log form is no good for me. It actually is it's hurting me. It's not allowing me to solve for this x. So you know what I'm going to do is I'm going to say, you know what? This is base e. So what if I change this from log form to power form? What if I say e to the 4th power, because e is actually a number, and I can take it to the 4th power, and then I say that equals, and that equals 2x plus 3. Then I can actually take e to the 4th power, which when I put my calculator is 54.598, and that equals 2x plus 3. I then can subtract 3, I get 51.598 equals 2x. I then divide by 2, and I get 25.799 equals x, and there's my answer.
Would we go back in after that and do the ln and like plug it in and all that, or
You
would
could
that
check
just...
it. You could check it. Yeah, you could definitely. That would check your answer if you plug this in for. So if you put x as 25 points, that right here, and you times it by 2, then you added 3, and then you hit the ln button. It's not going to be exactly 4 because we had to round it, but it's going to be like 3.9989. Like it's going to be so close, it's silly. Questions? Questions on anything I've covered today?